To my own discontent.
Remarkable. Hello, I'm Robin Vincent and welcome to Molten Music Technology. Today we're looking at the Native Instruments Komplete Audio 2. Here's a little USB interface. Look, isn't it quite cute? In a little box, it's got a knob, got some knobs on the front, it's got a shiny bit with some lights on, and a surprisingly few number of jack sockets. But somehow, during the course of this video, I'm going to have a go at showing what it can do. I mean, how do you review audio interfaces? It's always been a bit of a weird thing. I mean, I've read reviews of this that go, oh, like it's an audio interface. You plug things in and it's great. And it just doesn't seem to cut it for me. So I'm going to throw a load of things at it. I think I'm going to look at how well it performs within software. I'm going to look at the connections. I'm going to look at latency, because that's our favorite thing in the world. And hopefully, through all this messing about, you'll have an idea of whether this is any good for what you want to do. So first, the facts. Let's have a look at it in close up. Right, well at the front, obviously, this is what I would call your classic USB audio interface. You've got two channels on the front, two microphone preamps, which can also be instruments, can also be line level. Got a little switch to switch between line and instrument level. So you plug your guitar in, you turn it up, switch it to instrument, sort that out. You plug in the output from a synthesizer or from your mixer desk or something else that you want to record. That also goes straight in these front inputs here. These are called combi jacks because they can take both an XLR from a microphone and a normal jack cable from a guitar or a line input. So yeah, also microphones go in here. It has phantom power on this little button here, and that gives power to condenser microphones if that's what you're using. If you're using a dynamic microphone, that just plugs straight in. Two channels is what it's got. It's got some metering on the top here to give you some idea of what your input levels are doing, and a nice big fat volume knob. Also on the front you have a single headphone socket with its own volume control, which is useful, and you have this mix control between playback from your computer and direct input, which allows you to directly monitor through this interface. Now I'll explain what that means in a minute and how it doesn't exactly do everything perhaps you think it might. Now on the flip side, you just have a stereo output, line output on jacks again. And that's it. There's no MIDI, there's no monitor outputs or second speaker outputs, there's no separate phono outputs or anything like that. It's a good, simple USB audio interface. It's very much like the Komplete Audio 6, which is Native Instruments' long-standing audio interface, which has a lot more bells and whistles, and it's also made out of metal. This is made out of plastic. It's nice plastic, but it's made out of plastic nonetheless. It's not particularly heavy, but it doesn't move very far on your desk because of the nice rubber feet it has. It is solely USB powered, which is awesome. So you don't need to take a power supply with you. It just connects straight to your laptop, your Surface, your MacBook, whatever you're running, and will work. So what we'll do first is I'll plug a guitar in, I'll plug a microphone in, and let's record some stuff. First off, installing it on your computer if you're using Windows like I am here, and this review is going to focus exclusively on Windows 10 running on the Surface Pro 6, which is what I have here. Then you're going to need to install the drivers. You can download the drivers from the Native Instruments website and run the installer, and then you simply plug in a USB cable into the back. You'll get a light on, does a little flurry to say that it's installed, and Windows will see it and go, oh yeah, look at that, that's great. Not too difficult, not too difficult at all. That's what we like. Obviously, if you're running a Mac, you just plug it in, get on with it. But you know, this is Windows, man, so that's what we're here to talk about. So output out the back, I'm going to plug into a couple of jack plugs, and then we need to plug some stuff in. So here's my microphone down here. It's an AKG C3000, a classic, I think you'll find. So I take my cable the other end and I plug that into input 1. Doesn't matter whether I set it to instrument or line because it's seeing the XLR input as a microphone input. And it's all ready to go, almost. This sort of microphone is a condenser microphone and it requires powering. So you need to put on this little button here which says 48 volts. That's phantom powering. That sends a little bit of power from the USB up the cable into the microphone to power it. Very important you don't put that cable in your mouth. And then when I speak into the microphone, input, phantom power, microphone, 1, 2, 1, 2. I need to be able to turn up the gain until I get some kind of sensible level. As you can see, there you go, there's what we call a sensible level. Next up, I need a guitar. There's a guitar. I plug that into the second input, make sure the switch is on instrument, and then play to see what sort of level I get. The level is far too hot, so what I do is turn down the level on the gain knob on the front until I get something that's a bit more under control. And there you go. Excellent. Now, the Audio 2 is a simple audio interface. It's really stripped down, it's made of plastic, it's designed to be extremely good value for money while being a high performer. That's the idea behind it. That's what Native Instruments are trying to get across. And so they've had to shave off a few features along the way. One of the features is a regular monitor output. So at the moment, when I play something or I talk through the microphone, nothing is going through the interface. There's no internal mixing as such. There's no app which lets me route things to different places. And so I'm getting nothing out of the outputs. I can turn this all the way up. And nothing is actually going through out of the outputs at the back. That's not to say there isn't any monitoring, because there is. The monitoring is purely on headphones. So in order to hear what's going through outside of software, you need to have headphones plugged into here. But we're not going to do that just in a moment. We'll do that in a minute. But at the moment, we're just going to use the main outputs. So in order to get sound through this system, we need to run some software. So I've got Studio One up here. If I enable the inputs for monitoring, you should now get a mix of the sound. Can you hear that? So I've got my mic set up, I've got my guitar set up, I've got Studio One open here, I've enabled 2 tracks for recording. All I've got to do is hit record. That'll start recording, and I just have to start singing and playing something.
I was walking down the road to my own discontent. Didn't know what I would find, but I found a big gorilla who said I look really good in these shoes.
You know, something along those sorts of lines. Now, of course, the question is, how good was that recording? What sort of quality was it? How does the signal to noise ratio work? What kind of SPL levels was I getting? What kind of accuracy picture of the stereo field was the Audio 2 representing through that recording? Well, you know, it's really hard to tell. I've been thinking a lot about this, and I've been running signals through sonograms and spectra analysis bits and pieces, and I don't know really what you're looking at. I mean, what is it that you want? I think the best way to think about something like an audio interface is just to see it in price brackets. I mean, this is a sub £100 audio interface. What are the mic preamps really going to be like within that? They're going to be okay. I mean, it's a decent box. It's from Native Instruments. They sort of know what they're doing, but this is not going to be comparable to a £1,000 audio interface or a £500 audio interface. That's just not going to happen. But what you get is a good, clean recording. And it's easy to do, simple to use, and you could hear it straight through the box, monitoring straight through the software. Easy. So what we're left with? Well, we're left with a little bit of a recording. Let's run that into something like that and do that.
Down the road to my own discontent.
Right, so what I could do, right, I could add a bit of stuff. So let's do some vocals, put some compression on that, a little bit of delay. Let's add something a bit crunchy to the guitar. Yeah, well, so anyway, that's not really important what you record. All I really wanted to demonstrate there really is that you plug a couple of things in, you fire up your software, and you're recording and you're playing back. The quality of the sound is great. It records nicely. The playback is good. It's simple. You've got a nice big output knob on the top to make things dreamily easy. You're not trying to fart around with a mouse trying to find the volume up and down necessarily. You can grab it straight on the top. I love that. I love that about the Komplete Audio 6. In fact, the Komplete Audio 6 was one of the first that gave you this kind of form factor, where everything else just had all the controls really small on the front, whereas the Komplete Audio 6 put a number of buttons and this big volume knob on the top, which is fantastic. It's so much easier to get hold of. And now a lot of audio interfaces have that sort of thing, and the Audio 2 is following right along. Now, something which is probably more interesting and more pertinent when recording through the Audio 2 is monitoring. Now, I mentioned how it doesn't monitor out the back. I mean, on many audio interfaces, you get main outputs, which just take the playback of your system, and then you also get monitor outputs. And they tend to allow you to route signal directly through the box and directly straight out again. Why would you want to do that? Well, because of our old friend latency. What is latency? Latency is, for those of you who haven't heard me explain it 1,000 times already, is the time it takes for the sound to get into the audio interface, into the computer, processed by the computer, and sent back out again. There's a finite amount of time that it takes for the computer to accomplish that. And we experience that in a certain amount of delay between the sound we've created and the sound we hear out the other side. That is latency. It's the time difference between the sound and the response out the other end of the computer. Because when the computer is applying effects or mixing or anything else like that, it takes a certain amount of time to do it. And it even takes a certain amount of time to take the data through the computer and back out again, regardless of what effects you're running. So we are always dealing with latency. However, in the majority of cases, for the majority of audio interfaces, latency can be kept low enough for us not to notice. Not for everybody. Some people will always notice it. And for those people, we have this function called direct monitoring. Direct monitoring means that you send the audio in and straight back out again. So it doesn't go through the computer. It bypasses the computer so that you can listen to it directly. Why is that important? Well, if you're playing guitar and listening to it through the computer, it might not be quick enough for what your fingers are doing. Or you could be singing and listening to your vocal as you sing, as you tend to, and there be some kind of delay to that. It would feel off. It would feel behind what you're actually doing. In extreme cases, it's half a second behind, but that's not what happens here. We're talking about very small delays. And so in order to get around that, Native Instruments have built in some direct monitoring and a mix between monitor and host so that you can do it through the headphone socket. Just the headphone socket, which is slightly annoying. But never mind, only because I don't like wearing headphones particularly, but never mind. So what I'm going to do is we'll simulate that by plugging the headphone socket here into my system for recording and then record through here. Now, direct monitoring has nothing to do with the signal going into the computer because the signal is still going into the computer to be recorded. It's purely that rather than listening to it come out the other side, you're listening to it directly through the box. Let me show you what I mean. So I've got my guitar plugged in. We know I've got an input because the input signal at the top, but I'm not hearing anything out of the speakers out the back because I need to enable monitoring within the software. I can do that. So now we're getting signal through Studio One, through Amplitude, and into my computer over there for recording. So that to me feels pretty real time, pretty good, pretty low latency. Let's have a look at see what the settings are. So currently the Audio 2 is set to 128 samples, which is giving up an input and output latency of around 5 milliseconds. Now, normally speaking, what one would expect is something around 10 milliseconds or under is what's going to feel like real time. So that's pretty good. But let's say you're running a huge project. You had a lot of stuff going on because latency is also relevant to CPU power. because it takes a certain amount of energy of the processor to run at lower and lower latencies. So you'll find that as your project gets bigger, that once you start running out of CPU room, if you increase the buffer size, increase the latency, that'll make it easier for the CPU to handle the audio and so give you more room for more effects and more tracks and more bits and pieces. So when you're mixing, you might increase the buffer size, the latency, to allow you to add more effects. And then if you wanted to add a guitar track later, you'll find that perhaps it's not as real time as you would have liked. So let's up this to, say, 512 samples. That should give us an input latency of around 16 and output latency of around 12 milliseconds. That should be a lot more noticeable. Now that to me is feeling slightly sluggish. Not terrible, but just slightly sluggish. And it's in that situation that direct monitoring starts to become useful, because I could listen to my guitar directly through the headphone socket rather than listening to it through the software. Now obviously there's a caveat with that, because not hearing the effects, not hearing the amp modeling and other stuff that's going on may have an adverse effect on my performance, because ultimately the effects form part of your performance on a guitar. However, you can add those effects afterwards, and it's surely better to have an accurate recording rather than, I don't know, what is 6 of one, half dozen the other, really? Is it a good thing? Is it a bad thing? Is it more useful on vocals? Possibly. It just depends on what you're doing, but having a direct monitoring option is very useful. So let's check that out. Now, as I said, it only happens on the headphone output. Other audio interfaces have monitor outputs on the back that can allow you to also directly monitor through those. The Audio 2 is a simple audio interface, so it doesn't have that kind of facility, so everything's going to have to happen through here. Okay, all I've done is I'm taking the output from the headphone socket here now, just through a little hum eliminator box, which is allowing me to connect it to my main outputs, which is then going over there to that computer to record everything from this computer. Does that make sense? I don't really care if it doesn't, except that all you got to know is that we are now hearing the headphone output. So let me put that all the way across to host, so we should be able to hear amplitude and the distorted guitar. Yeah, you can hear that all right. Now, if I turn this knob here that says host and input all the way over to input, now you should be getting purely the clean guitar sound, yeah? So now you're hearing purely the guitar, and it's not going through the software. Therefore, we should be able to get that in absolute, near as damn it, real time. Now, if I put it half and half, so you get the guitar that's going in, plus the guitar that's coming back from the software. So yeah, getting a mix is helpful because you're often playing along to something, so you're going to want to be able to hear what it is that you're playing along to, although you will also get what you're playing along to out of the back of here. So it gets complicated quite quickly, and how do you actually use that and how useful is that? This is the one thing about direct monitoring that's always slightly, I've found annoying, because generally speaking in life, when I'm recording with the computer, I'm using the computer for everything. It's my sound source, it's my effects box, it's my studio, my mixing, everything. And when I'm recording instruments, I tend to want to hear those effects because that's part of my performance. And so I tend to, normally speaking, monitor directly through the system and deal with whatever latency I come across. Obviously, if latency is too bad, you can't do it, well then you can't do it. But in my experience, it rarely is. If you can get under 10 milliseconds, it feels like real time, you're all right. So all this sort of general fuss you get with direct monitoring, I find that to be perhaps a little bit unnecessary. However, it is there. And so if you wanted, for instance, just to plug your guitar in and have it mixed with the playback from your DAW, then you can do that very easily, sticking that halfway between. You don't even have to set up a track for your guitar because you're not wanting to monitor those effects if you just want to monitor directly. And that's fine, that's groovy. Now, so far I have to say, in using this and playing around with this, that the latency has been excellent. As far as I can hear, but maybe it'd be really good to try to confirm that with some proper tests. Let's see if we can actually measure the difference between the direct signal of the guitar coming through direct monitoring and the signal of the guitar going through the software. Because that will be able to tell us whether the figures in the Audio 2 control panel, whether those are accurate, whether those are giving us good information, and how well exactly this is performing. So a little bit of genius here. I've got one output going here that's being recorded and another output coming from the direct monitoring headphone output here. I'm going to stick those together and record them on my other machine, and then I should be able to see the offset between the direct signal and the signal going through Studio One, through the effects and out the other side. We call this the round trip latency because there's a latency going in for the audio data being processed in through the USB bus into the computer, and then the computer processes it and it comes out the other side, and that's another latency, and that's called a round trip, in and back. Input latency, output latency, a round trip, those two combined, and that's what hopefully we can measure. How are we going to do that? Well, we'll set this to, it's on 512 as it says. We can bring up the control panel and set it in here, buffer settings. And this tells us what it believes it should be. It says the input latency should be 16.1 and the output latency should be 12.59. And that should give us a delay. Now, if we set that down to 256 samples, that should take the latency down to 10 and 8.5 out, so a round trip of 19 milliseconds. Can you hear that still? I don't know, I can't really from where I'm sitting, but then I don't have headphones on, which might be helpful at this point. Let's go down to 128 samples. That says the latency should be 5 in and about 4.5 out. So we're getting nice and low now. .64 samples, which it says is 2.95 and 2.5. So you've only got a 5 millisecond round trip now, which is quite low. Very low indeed. Now, the fact that this control panel here goes all the way down to 8 samples is quite remarkable in of itself. I mean, it makes me think that perhaps the drivers are written by the same people who did the audio fuse, because they also had drivers that went down to ridiculous levels of samples, like, 16, 8 samples, that kind of thing, which is no time at all. It's no room for the processor to process the audio, but it's there as an option. And if it works glitch-free, then that's got to be a good thing. I mean, that's part of this struggle, if you like, with latency, is that the processor has to be able to deal with it. You can't just take the latency down to nearly nothing and expect that not to have an impact on your processor. It absolutely does. So your computer will come into play here, and the latency that you can go down to will be subject to the power of your processor, how well it can handle that. And it's not about filling up the processor, it's how quickly the processor can act on that data, and whether it can do it glitch-free. So there'll come a point at which it will start to glitch, which is going to be difficult to hear with the guitar, perhaps with a distortion effect on it. But this will probably become more obvious when we start looking at virtual instruments. But for now, we'll try 32 samples, see if that works. So that's down to, 4.7. 16 samples, that's 1.8 and 2.5. And then 8 samples. Now there, you can hear that glitching, yeah? Now the glitch is to do with the processor not being able to cope with the data that's going through it. It can't process it fast enough. There's not enough time. There's literally not enough time for the processor to sort out that audio, apply the effects to it and give it back to us in some kind of sensible way. And so the audio stream gets corrupted and you get glitches in it because there's gaps where the CPU hasn't filled in all the information. And that's a trade-off that you get between processor and latency. The buffer size of the audio interface, which sets the latency, and the processing power required to achieve that. However, getting down anywhere near 16 samples, 8 samples, is extraordinary. Under 5 milliseconds round trip latency is just amazing. Totally amazing. Now you may have noticed this safe mode tick box here. Now safe mode is all about adding in an extra little bit of latency just to ensure that the playback is right. So even though you're going down in latency and reducing the input latency, so getting a more and more accurate recording, the safe mode switch is holding the output latency slightly higher just to ensure glitch-free playback. It's not actually working when we're down to this level. But if I uncheck that box, that'll take us down to 1.5 milliseconds, given a round trip of just over 3 milliseconds, which is just phenomenal. But my system can't handle it. If you were to plug this into a big desktop system, then more than likely you would get that to work. But for now, I think something at around 64 samples. I mean, let's face it, normally speaking, I would run any system that I'm running, desktop or otherwise, at either 128 or 256. Because 128 gives me under 10 milliseconds, completely fine, as far as, damn it, as I'm concerned, real-time latency. And so the fact that the Audio 2 can go much lower than that, and still have some kind of sensible glitch-free playback is really good. So let's have a look at the left and right comparison to see whether the latency is actually matching up with what it's supposed to. Right, over this side of the shed, we have the recorded audio into my software here. The top channel is the recording of the guitar going through Studio One, through Amplitude, through the effects, and into here. So that's the delayed channel. The bottom one is the direct guitar coming out of the headphone socket, the direct instrument coming straight back out again. And so by measuring the offset between these two ways, we should be able to see for real what the latency is. Not the latency that the software is telling us, because the software lies all the time, but the actual latency that we're experiencing. The difference between those two waves is going to tell us exactly what that is. Now, it can be difficult to measure exactly because you've got a little bit of attack because it's going through some amplification software. So in knowing exactly where that point lies can be a little bit difficult. But I'm not trying to say that this is some kind of lab experiment. I just want to have a go at seeing if we can work out exactly what the latency is all about. So this was 512 samples, which was supposed to give us about a 16 in and a 12 out. So that's what, 28 milliseconds round trip latency. And down here, right at the very bottom corner, is what this selection is, this current selection. We can see that we get about 26 milliseconds. So it's reporting at the moment about right. So let's then move to 256. Now there I'm getting about 22 milliseconds, and 256 was supposed to give us 10 in and 8.5 out. So again, that's not far off. That's about right. Now at 128 samples, it reckons that you're getting down to about 10 milliseconds. And this is saying 13 milliseconds. So that's not far off. That would be 10. So could that be the start of the wave? Maybe. Maybe, but I'm inclined to think it's more likely to be there. For 64 samples, it suggests it would be 3 milliseconds in and 2.5 milliseconds out. I don't think I've quite got that. This is more like 9 milliseconds, but that's still excellent nonetheless. So it seems that with the rest of these, anything under 64 really, once it's cracked that 10 millisecond barrier, it seems to sort of get stuck there. So even though the software is telling us that there's less latency going on, things like a round trip of 5 milliseconds, what we're finding is in all of these, I mean, this is apparently at 8 samples, but I'm still getting 9 or 10 milliseconds, depending on where I put this line. I mean, there's 10, there's 9. Can I really go any further down? I mean, perhaps I could bring this in a tiny bit at this end, but, you know, the wave has already started. So just under 10 milliseconds, it appears. Now, I should stress that under 10 milliseconds round trip latency is great. That's great off any audio interface. And what we're going to do in a moment is look at how that translates to purely using the output latency with virtual instruments, which is another perhaps more important element of latency and audio interface performance. So using an audio interface for virtual instruments is vitally important. You can't use the onboard sound. It's just not up to it. It's just not. I mean, there are wonderful things you can do with Wasapi drivers and ASIO for all, and you can get that latency down on some occasions with some synths in some places. But it's too much of a hassle just so that you don't have to take an extra box with you. Yeah, I can understand the attraction of wanting to use just the headphone output, but if you want to get decent performance and a decent sound quality from virtual instruments, then an audio interface is what you need. And this is why I'm trying this out, because I need for myself a handy little, relatively small, easy USB powered audio interface to run with virtual instruments when I'm out and about on the road, as it were, like that ever happens. I don't know, I could be, it might happen, I might be out there. But the point is that this is going to give you much better performance. Much better performance in terms of how many instruments you can run, much better performance in terms of the latency and delay that you hear, and how many voices you're going to get, and also just the blinking sound quality. Not to mention the fact that you have a volume knob and a headphone knob. Things like that are important. They're important. So let's demonstrate that. So to do that, I'm going to take this little fella. This is a little an M32, which is another Native Instruments little box. I'm just using it for MIDI. I'm not going to do anything partial or special with complete software or anything like that. And that should all just work. Now, in case you're interested, how on earth I'm plugging all these things into the Surface Pro, well, I've got just a passive hub. This thing here, it's just a passive hub. Got 4 ports on it. Let me run the iLock for Pro Tools. Lets me run a dongle for Cubase, an audio interface, and a MIDI keyboard without any bother at all. So that's plugged in. Let's turn on something that I can play in order to make a sound. Oh, now the other thing I'm going to plug in is this here, which is just a sustain pedal. Just a sustain pedal, nothing scary. That's all it is, so that I can make some sustained sounds. Sounds pretty super to me. Now let's go to a piano, which is going to work it a little bit harder. This is the Arturia piano V2. And what I'll do, I'll play a little bit in, and I'll keep the sustain on, because that's going to tax the processor a little bit more. Nice, it's lovely. So what is the audio interface set to? Let's have a look. It's set to 64 samples. It reckons that's giving me 1.5 milliseconds. Ooh, now I wonder if that's true. See how much further we can take that. Let's go down to 32. Seems fine. Let's try 16. Yeah, I mean the output's distorting a little bit, you might have heard there, but that's purely the output level getting a little bit too high, so I might have the gain up a bit far. Go down to the magical 8 samples. Now down here I can see the CPU meter on the instrument itself having a bit more of a hard time, but it's still dealing with it. Let's open the control panel, see 8 samples, safe mode. So even though in here it's saying it should be 0.2 milliseconds, it's not, because safe mode is on, which means the output latency has been restricted to 2.5, although as we know it's probably more than that when we measured it using the guitar thing a moment ago. But let's take safe mode off. Now it reckons 1.5 milliseconds. That is the sound of a processor not quite being able to deal with the audio that's it's being fed. It's been sent a whole load of data, this sort of data, and it's going, oh my goodness, I can't quite keep that all juggled in the air all at once. And so it drops some bits and we hear that as noise. That's the magic of having a buffer size which is too small. Now, if I was running this on a large desktop computer with masses of processing power, I might be able to do this glitch free at this point. It would depend. Let's put safe mode back on, which bumps the output latency to 2.5 milliseconds. And there it's back. I mean, that's quite remarkable. If it is 2.5 milliseconds, that's extraordinary. I mean, because in my experience of audio interfaces, most are around, can handle 10 milliseconds. You know, all of them can get just beneath 10 milliseconds. You can usually get down to 128 samples, which usually equates to just under 10 milliseconds, sometimes down to 5 milliseconds. And that feels all right, feels good, feels very playable. Some very posh audio interfaces like RME, Motu, that sort of stuff, can get down to 3 milliseconds and under. So if this is doing under 3 milliseconds, then that is excellent. And that's the sort of thing you want. You want that for your audio interface. If it can get down that low, it means you're going to have a very snappy response. I mean, to my ears playing it, it sounds all right. I can't actually say whether that's under 10 or under 5, because I can't measure those sorts of things with my ears necessarily, because my playing is so sloppy and interpretive that I don't really know. However, we can measure it like we did before. We can measure it by triggering a sound at the same time as recording a sound generated by a synthesizer. And that will enable us once again to see whether we can measure that difference, that offset, to see whether this is actually performing as well as it says it is. So far, we know that its round trip latency really does kind of stop at around 10 milliseconds. At least that's what we found in the testing that I did. So is there a similar thing with just using output latency? Because that's what we're using. Because no signal is coming in, you get MIDI obviously, but MIDI travels at 10 times the speed of light. We know that already. But because we've got no audio signal going in, there's no input latency. All we've got is the computer generating the sound and that coming out, and that's the output latency. So that's all we have to deal with. So how are we going to test that? Well, I'm going to introduce a synthesizer to this, and I'll show you what it is we're going to do. So I'm going to use this. This is the Behringer MS-101. It's very new, very shiny. It sounds an awful lot like an old Roland keyboard. But anyway, so the plan is that this is attached via USB to the surface and triggering massive. Like that, hear that? Yeah, okay. But at the same time, we're going to have the sound from the MS-101 go out directly. So, like we did with the monitoring test that we did, we're going to record the sound of this directly along with the sound generated by the computer. And those two sounds together, we can measure the offset between those recorded waves and it will tell us exactly what the latency is. I love this. It's my new best test that I first did on the Audio Fuse in a review a little while ago. But it's a brilliant way of doing it, and you can do it at home. If you want to see what your audio interface is capable of, what sort of latency you're actually getting rather than what the software is trying to tell you, this is just a brilliant way of doing that. So that's the sound of Massive. Turn that down a second. That's the sound of the MS-101. So I've set the latency on here to be the maximum, which is 1024 samples, which should give us an output latency of around 50 milliseconds. So what does 50 milliseconds sound like? Should sound like this. Nice, yeah? That's latency. That's what you can hear. So the difference between those two sounds is the amount of time it's taking the computer to generate the sound from Massive. That's proper latency. It's not a delay effect. No. That's proper latency. So what we'll do is we'll now reduce it down to a sensible level and do some measurements. So let's go down to 256 samples. Let's not mess about. Let's get stuck into that. 128 samples, which should have an output latency of 4.5 milliseconds. Now I can't hear that. I can't hear that there's any difference between that. 64 samples. 32 samples. 16 samples. 8 samples. And also we'll try it without safe mode. I mean, Massive is kind of many ways much simpler than that piano that we were playing earlier that gave us crackles. So on a basic sound, Massive should be able to cope with that, and it seems to. And it might be interesting to see whether we get any phase in between them. See, that's detuning slightly. That's quite nice. Anyway, I digress. Let's go and check that out. Right, so back over here again, looking at our waveform. If we check out that first one, which is supposed to be around 50 milliseconds, which is here. The top one, obviously, in this case, is the direct sound, because that comes first, and the one beneath it is the one generated by Massive. So let's have a look-see. Ah, look, that's interesting as well. You can see the different waveforms. So we're getting a simple sawtooth out of Massive, whereas out of the MS-101 we were getting, I think, a sawtooth and a square wave. And so you get this combination waveform. Anyway, that's by the by. So let's measure those up. Much easier to see than when dealing with audio from an instrument, because we get a definite start point. I mean, yeah, there's a little bit of play because there's the physical action of pressing down a key, and when that actually fires that sound, as opposed to when the MIDI gets transmitted to the computer. So there are, you know, error correction and a little bit of margins in there, but let's just have a look at what we've got. So this, which is supposed to be an output latency of 50 milliseconds, says here 90 milliseconds, it says. So do you see what I mean about the information in the software? What it says in the control panel is not necessarily what you are actually getting. Even if we were to build in a certain amount of error correction, that's still wildly away from what it's supposed to be. Interesting. So let's go to the first lot, which should be 256. Let's get a good waveform difference. So at 256, it's dropped to now 13 milliseconds. Let me just check to see what it's supposed to be. Now it reports in the software to be 8.5 milliseconds. I've got it here to be 13. So that's 256. Let's go down to 128. That's pretty good. Now that appears to have dropped to 6 milliseconds, which is excellent. It says 128 should be 4.5. Next lot should be 64. Now that's also 6 milliseconds. And that's suggesting it should be 2.5. So it's at this point, 2.5 milliseconds is as low as it goes under safe mode, but I will keep going on these other ones. So this should be 32 samples. Oh, that looks pretty close. Yeah, that's none at all. Let me try another wave. There might have been something that went wrong there. Oh no, well this is looking excellent. Look at that. Okay, that's looking like 1 millisecond to me. 1 millisecond. So this should be 16. Yeah. See, that's nothing at all. Then we had 8. Again, just about a millisecond. And then we had it with safe mode removed, which does not seem to have made a whole lot of difference. But now look, you can see it's pretty much instantaneous. See, the latency is now so low that the bottom one, which is coming from massive, is actually beating the direct one from the Behringer. Okay, so strange things going on there. I mean, I always like strange things to happen, but what I'm going to do now, I'm going to do the same test just quickly, just to cross-reference it with a more intense piece of software like the piano we played before, just to see if there's a difference there. Let's try that. So how interesting is all that? I mean, you don't get this kind of level of detail on anybody else's channel. Oh no, I get right down to the nitty-gritty of what something is all about. And what is remarkable is that the latency we're getting on the Komplete Audio 2 is brilliant. It's really good. I mean, it's not just average or mediocre like you'd expect from a box that costs 100 quid. No, it's top notch. Top notch. What a good job. Now there's one other factor, one other annoying factor, which is the CPU factor. And that is something that we've seen in the way that the piano crackles when you go down too low. But at what point does the CPU really get troubled by this? And that's worth looking at. So there's one more thing we'll go through. And we have to do that, sadly, in Pro Tools. Why? Because Pro Tools has this really good CPU meter in it, which is no nonsense, doesn't mess about, and says, look, this is rubbish most of the time. So we're going to use Pro Tools, which sadly on the surface, it's not ideally suited because Pro Tools still doesn't cope with scaling very well. It sort of does, and then it really doesn't. And that's, I find that rather frustrating. Because if you load up a plugin that it doesn't like very much, it just goes stupidly small, which you'll see in a minute because I can't seem to get it back to how it was before at the moment. It's continuing to be really small. Looks good at the moment, everything's fine, everything remains fine. And then, oh, it just goes stupid. And it's shrunk, the screen has shrunk, it's gone crazy with the scaling and the menus no longer fit on the top. And it's, oh, but there we go. There we go. So if I can see this even remotely, I will try to demonstrate with a bit of luck what the system usage is doing, what the CPU is doing when using different latency settings. Alright, so for this, what we need to be looking at is the system usage meter here, which is impossibly small, and I don't think you can see it, but hopefully you'll get a general idea, although all you seem to be seeing is my reflection, which is not helpful either. Oh, I don't know, this is a bit of a disaster. This is such a scrappy video. I do apologise that it does not have the usual polish that you've come to expect from me. This is a bit all over there. That's what audio interfaces are about though, because they often don't really make any sense. They give you figures which are lying about things. They have funny features on them that don't seem to make a lot of sense. They're difficult to demonstrate because you're trying to suggest that you can hear the sound quality of something, which of course you can't because it all depends on your own system and what you're listening to it on. And so it turns into a bit of a conundrum. And so what I'm trying to pull together here is all sorts of thoughts I've had on how best to demonstrate this and show that. And it just comes together as a bit of a scattergun explosion of bits. But there we are. But anyway, so system usage down there is saying not really a lot. It's just trucking along. And you play a sound, it's just massive, we're worried about, not going to do any more latency testing. And we are currently running at 128 samples. That's the buffer size. And it's all fine. It's all good. Now, of course, Pro Tools uses a different way of doing things. And so it doesn't even offer you anything below 32 samples. Why is that? Well, I'll show you, I suppose. I don't know. I'm never going to get to a why because it's Pro Tools. There's no why in Pro Tools. Pro Tools just is. It is, and it enforces that upon you. So let's go down to 64 samples. You have to hit OK. Everything has to be okayed. Pro Tools needs to rethink about itself and then give it another go. Okay, so at 64 samples, we've had a little bump in the system usage. A little bump. Now that shows you that the processor is now having to work hard or harder to maintain a glitch-free audio experience. Let's come down to 32 samples. Hit OK. Now the system usage has gone mental. It's going, oh, this is really hard. Playback is still good. We're getting some red peaks here on the CPU usage, which hopefully you can see. But I hope that demonstrates that as you reduce the buffer size, the CPU has to work harder. It's often difficult to see that exactly, but Pro Tools is the only one that really gets that and sees that there's actually not a lot of room left for your plugins, not much room for your effects or mixing, because it's working so hard at such a low latency to do the 1 millisecond, 2 millisecond thing that it's been trying to do. And it's at this point that you need to back off to give it some room. Now, as I said, it doesn't go any further down than 32, but I can force it. So I can open the control panel for the Audio 2 and take this here down to, say, 16 samples, like that. Let's see what happens with that. Oh, look, all the system usage thing has gone away. Yes, it has. Why is that? Playback is perfect. Because it's gone, screw you. It's not gone down to there at all. It's bumped itself back up to 256 samples. Because Pro Tools knows that 16 samples is a ridiculous buffer size to deal with. And so it's elected to go back up to 256 all by itself, even though you selected 16. It's nuts. And so because of that, you're still getting great low latency, as we know. Under 10 milliseconds it was, 5 milliseconds it was, things like that. At 256 samples, giving Pro Tools loads of room to do its instruments and its effects and low latency instruments all at the same time. Right, so where does that find us then? Where does it place this in the pantheon of audio interfaces? Well, who knows? All I can say is from my testing here that it sounds all right. You plug guitars in and mics in, it works, sounds all right. Doesn't have monitoring outputs on the back, which is a shame. That's something which is missing, but on a sub £100 audio interface, that's okay, you know. The quality of the knobs and bits and pieces on the front are great. Headphone monitoring through here, yeah, that's all right. Mix between host and input, that's fine. It's good and standard. Got no real complaints. I love the big fat output knob on the top. I'm always a fan of that sort of thing. That's great. Input monitoring, that seems to work. So on the whole, it's not a bad little chunky box of plastic. But what is remarkable about this is the latency performance. I'm quite stunned by it, really, because I've come in my old age to assume things about latency. It's just one of those things. Well, I've come to accept that around 10 milliseconds is all one gets. That's what we get. That's what we get given, except in extreme circumstances. I mean, with the audio fuse from Arturia, which I use normally, that, when it first came out, had appalling latency on Windows. That happens a lot because a lot of these products are developed on Core Audio and on Macintosh, and they work fine and very low latency. And then it comes to Windows and it all just goes a bit pathetic. I don't know why that is. I just have to assume that developers for audio interface companies are mostly Mac based, and Windows is a bit of an afterthought, which is a shame because Windows is by far a much bigger market. But I don't actually know. I'm just saying. So when the first version of a driver comes out for Windows, you kind of treat it a little bit carefully. And as I say, with most audio interfaces, you would get down to under 10, 8 milliseconds, 7, 6 milliseconds. I mean, that's generally where you find Focusrite USB audio interfaces or PreSonus USB audio interfaces, because although they can do lower sometimes, you often get that crackle. You get the crackle and you can't really use them. So you generally stick to 128, maybe 64 samples if you're really pushing it on something like a Focusrite audio interface. But this fella, gee whiz, down to allegedly 8 samples, and it was quite extraordinary. It was doing it. I mean, in safe mode, but measured over there, down to about 1 millisecond output. I mean, that's amazing. And it was still working. Now, your processor is going to have to work hard to maintain that, and that is a factor. But once you're back up at 64, 128, it was a breeze. Wasn't worried about it in the slightest. 128 samples, buffer size, running this, doing it under 5 milliseconds output latency, and a 10 millisecond round trip latency. So I couldn't seem to get any lower than 10 milliseconds on the round trip, which was interesting as well. But all in all, remarkable driver performance. And, you know, in the future, if Native Instruments want to release something more complicated, something with more features, then the driver architecture so far really bodes well for that. Could be very interesting indeed. So yeah, summarise, what a nice little box. That'll do, won't it? It does have a little baby one called the Audio 1. And with that, they take out one of the mic preamps just to make it a bit cheaper. So you've got one mic input, one instrument input. Other than that, it's more or less the same. I don't think it's that useful because 2 microphones does become helpful at some time. So does 2 instruments, 2 of anything. But there's only about 20 quid between them. So, you know, take your choice. But I imagine, in fact, I know that the driver architecture for them is the same. So if you just need something to give you a good quality output and low latency then throw this in your bag. That'll do the job. Well, I hope that was helpful, and do stick around and check out the channel. You'll find all sorts of reviews on MIDI keyboards, synthesizers, audio interfaces, bits of software, Eurorack, all sorts of bits and pieces, stuff about the Surface Pro 6 and how well that works, and setting up Windows, running music production software, the whole stuff you'll find. And if you're feeling really daring, you could head over to the Patreon page, throw me a few dollars and keep me supported in doing all of this nonsense. That would be great. And in the meantime, go and make some tunes.